Welcome! I am Teacher M. This math tutorial video is focused on limit properties. If you are interested to learn more about this topic, stay and watch the entire video. In this limit properties video series, 8 limit properties will be covered for the entire series. These are constant, identity, scalar, sum and difference, product, quotient, power, and radical property of limit. For this sixth episode, the video is focused on the quotient property. Before you continue to watch this video, it is advisable to learn first the following properties: constant, identity, scalar, sum and difference, and product property. These enumerated properties will be used in this video and will be not explained on details. Quotient property says that the limit of a quotient of functions is the quotient of individual limit, where b and c are real numbers, n be a positive integer, and f and g be functions with the following limits, L and M. To give you further explanation, let's use an example. What is the limit of a quotient of 1 and the difference of x and 1? The quotient property is telling us to get the limit of the dividend and the limit of the divisor. By applying this property, we have the limit of 1 as x approaches 2 divided it by the limit of the difference of x and 1 as x approaches 2. This is how we apply the quotient property properly. To solve the entire example, use the other limit properties. It is possible now to apply limit property in the numerator, but for this example, I will make the denominator simpler first by applying property. In the denominator, apply the sum and difference property. The denominator becomes the difference of the limit of x as x approaches 2 and the limit of 1 as x approaches 2. Copy the numerator. For numerator, apply the constant law. Then the limit is 1. For denominator, apply identity law to find the limit of x as x approaches 2 results to 2. And apply constant law to the limit of 1 as x approaches 2. It results to 1. Simplify the denominator by getting the difference of 2 and 1, which is 1. Then, get the quotient. Thus, the limit of the quotient of 1 and the difference of x and 1 is 1. To make it clearer, let's do another example. What is the limit of the quotient of the difference of x and 3 and the difference of 3 and x? I'll give you 5 seconds to decide whether to pause this video and give it a try or continue the video. Let's proceed. Apply the quotient property. It gives us the limit of the difference of x and 3 as x approaches to 1 and limit of the difference of 3 and x as x approaches to 1. Apply the sum and difference property to numerator and denominator. In numerator, it becomes the difference of the limit of x as x approaches 1 and the limit of 3 as x approaches 1. In the denominator, it becomes the difference of the limit of 3 as x approaches 1 and the limit of x as x approaches 1. In numerator, apply the identity property to get the limit of x as x approaches 1 and constant property to get the limit of 3 as x approaches to 1, which give the answers 1 and 3. In denominator, apply the property to get the limit of 3 as x approaches 1, which give an answer 3. And apply the identity to get the limit of x as x approaches 1, which leads to the answer 1. Simplify both numerator and denominator. And we have negative 2 over 2. Get the quotient? Then, the limit of the quotient of the difference of x and 3 and the difference of 3 and x as x approaches 1 is negative 1. Last example, what is the limit of the quotient of the product of x and the sum of x and 1 and the difference of 2x and 1 as x approaches 2? I'll give you 5 seconds to decide whether to pause this video and give it a try or continue the video. Let's solve it. Apply quotient property. And we have the limit of the product of x and the sum of x and 1 as x approaches 2. And the limit of the difference of 2x and 1 as x approaches 2. Apply product property to numerator. The product of the limit of x as x approaches 2 and the limit of the sum of x and 2 as x approaches 2. Apply sum and difference property to denominator. The difference of the limit of 2x as x approaches 2 and the limit of 1 as x approaches 2. Apply sum and difference property to numerator. The sum of the limit of x as x approaches 2 and the limit of 1 as x approaches 2. Next, apply scalar property. Factor out 2 in 2x and get the limit of x as x approaches 2 and write the limit of 1 as x approaches 2. Apply identity property to first factor of the numerator, which is the limit of x as x approaches 2 is 2. Apply again the identity property to the second factor, which is the limit of x as x approaches 2 is also 2. And constant property to the limit of 1 as x approaches 2 is 1. In the denominator, we write 2 and apply identity limit to limit of x as x approaches 2, which is 2. Apply constant identity to limit of 1 as x approaches 2 is 1. Simplify the numerator by getting the sum of 2 and 1, which is 3. And simplify the denominator by getting the product of 2 and 2, which is 4. Simplify the numerator and denominator further by getting the product of 2 and 3, which is 6. And getting the difference of 4 and 1, which is 3. Get the quotient of 6 and 3. Then, the limit of the function as x approaches 2 is 2. This is how you apply the quotient property of limit to find the limit of a constant. To learn more on the remaining properties, you are warmly welcome to watch the other videos. If you learned on this video, hit the like button and subscribe to be updated and notified for other math lessons. See you!